So welcome everybody in the name of IRISCC to the second session of this research infrastructure webinar series in research infrastructures related to IRISCC. As you know, IRISCC aims to integrate climate change related risks services coming from 14 European different research infrastructures. And today we are having two additional ones from the ones we already saw in our previous session. Today we have the pleasure to have Alexia Katsanidou from GESIS to introduce us GESIS, which is the European Infrastructure Institute for the Social Sciences. And we also have Hajo Baumgarten and Marvin Stecker from the University of Vienna, who are going to be talking about OPTED and MEDEM, which is the Observatory for Political Text in European Democracies. Yes, as you may have noticed, we are going to be recording this session for dissemination purposes. So that the rest of the participants or people interested can access it in our YouTube channel. But we will just keep recorded this informative part. There's going to be a question and answer session at the end of the session, and that one will not be recorded so that it promotes discussion easier. But as in the previous session, we just asked the speakers today to basically fill in these three questions. So what is your research infrastructure about? And how is your research infrastructure fitting in the context of IRISCC? And if they could maybe give us some climate change risks related cases in the case of their infrastructure. So that's all what I wanted to show. I'm going to stop sharing my own screen and we're going to start alphabetically. So I'm going to give the floor to Alexia and let know more about GESIS. Alexia, whenever you're ready, the floor is yours.
Sorry, I have too many screens and I got lost on how to unmute myself. But thank you so much. I hope you can see my presentation already. Perfect. That's great. So we have today, as you already said, Benyat, the two infrastructures that come from the social sciences. So I think my first question that I want to answer is how GESIS fits in everything, and can, in fact, the social science infrastructure be useful to the natural sciences and to the question at hand. So I'll start presenting GESIS and try to give you ideas on how actually this can be useful to the natural sciences. So GESIS is a German institution. It's part of the Leibniz Society. So some of the institutions that are members of the IRIS can find themselves again in this context. But what we do, we are the largest European institution for data infrastructure services in the social sciences. And our focus is on the quantitative side of research. So it's quantitative empirical research. And our portfolio includes mainly surveys. So we survey the population of Germany, but also deliver data on the population of Germany in European and international survey programs. And we also collect digital behavioral data, so social media data, web tracking data, everything that has to do with how society works, but on the internet. And we have a big portfolio of studies. And what we also do is we link this data. So we try to keep integrated, linked information on data, on literature, and on various research projects. And we work through the entire research design life cycle. We have our own survey programs, but we also, as I said, contribute to existing ones that are not only our own. And we do research on various themes, on contemporary societal issues like climate change, but also on more applied things like computational social sciences, computer sciences, and research data management. And we also have a big set of training programs for people to use these types of data. I already said we are part of the Leibniz Association. This is our structure. Unfortunately, it looks a little bit more blurry than what I have intended. We have 6 scientific departments, and you can see among these departments that we basically have departments where we collect data, departments where we curate the data, and departments where the data are made available. And I am here, survey data curation. And the reason why I'm here in front of you is because in the survey data curation, we offer the links to the natural sciences. But on that, I'll tell you more later. This is us, so you know how big we are, and the budget and how much is third-party funded and all that for those of you who are interested in these kind of numbers. For an Institute of the Social Sciences, I can tell you this is big. And also the budget, because of the data collections, is very big. Our services. We learn to structure our services so people can navigate better. So in our first phase, we support people in their planning phases of the study, how to collect data and how to make sure that the quality of the data is right and their data is representative. The second phase, we help people in finding existing data and accessing this data. And then we move on to supporting people with different services in processing and analyzing data. For example, the data linkage that we do, and I will show later, falls in this phase. And finally, when you have your data ready and they are relevant for the social sciences, we archive them for you, for other people to find. Just to get an idea on how important these data are, they are being downloaded quite a lot. During the pandemic, people didn't have much else to do, and they even downloaded up to 100,000 times our data sets. So it's quite a bit. Then they had also other stuff to do when the pandemic ended, and we are back to more normal downloads. Also, people who download our data are not only looking at them, but they're also publishing with them. So the impact that we have on publication is also quite significant. So we can say that the data hosted at GESIS influence quite a bit the social science publications on quantitative publications. Just to give you an overview of what data we're talking about, maybe some of you have seen this type of logos. Maybe the most important one you might have heard of is a Eurobarometer that is collected by the Commission. So here you can see a set of like long-term survey programs that are collected within Germany, but also data like the European Social Survey or the ISSP, the CSES, that focus on Europe and on the whole world. So what we do from our side is we collect the German surveys and we deliver it to the European or international secretariat that puts it together. We host some of the secretariats ourselves, so that's also another thing that we do. Now, in terms of infrastructures, one thing that we do, and it's also relevant for climate change in this case, is we work together with other infrastructures to make this data interoperable and harmonized. And within the context of infra for NextGen, for example, that is a running Horizon program that brings together the social science infrastructures, we have harmonized existing survey data on climate change. So one thing that it's interesting for you to know is what people believe about climate change in general. Are they worried about it? Do they have opinions about how climate change can be tackled? So here we provided information, survey, microdata, so individual level, and by individual I mean people, individual people, how they answer these questions across Europe, across time, and this is targeted to policy research because this is what the Commission wanted at the time. So because these issues of climate change are very much focused on specific locations, we thought that it's important to know where these individuals actually live. So the first thing that we did a few years ago is that we started georeferencing our studies. And by georeferencing means that we get the addresses of these individuals and we transform them into specific locations. So knowing where the individual lives on the map with coordinates, we can link it then to specific information about the traffic noise they are dealing with, the soil sealing, or the immigrant rates in their area. So we can we have different kinds of usage for this kind of stuff, and a lot of interesting studies came out that we didn't even count on. We initially thought context for us would be the natural context, but you will see that people are very creative with this kind of information. So what we did, we offer point coordinates, we offer polygons around the individual location and grid cells where the household or the workplace is located. And it's important to say that we use temporal references using standardized dates, for example, on the interview date or exposure to certain events. So if you have a flood, for example, or a fire, forest fire, you will know when exactly that person was located in this. Of course, this kind of data are very sensitive. So geocoordinates, even though they're based on addresses, are not stored in the same data set. So we really have to be careful what we give out. So everything is linked by us and then given to you in a secure location or in a secure system. So if anybody of you is interested in knowing what impact, for example, in specific measurement on a specific natural situation, to what extent this had an impact on people's responses, that would be the case that you could use. And what we identified is how these data were actually used. And these data were used, for example, on political science. How do extreme weather events influence green voting? Quite a bit, actually. Floods, forest fires, heat waves, and all that. To what extent these have an influence on the way people behave when they are in front of the voting booth. Or in sociology, how does air quality affect patterns of community cohesion? You'll be surprised that this is also the case. Or in economics, how do changes in land use affect regional economic development? In public health has been used also quite a bit. How does the increase in heat waves influence hospital admissions differently across regions? Or in peace studies and conflict studies, how do nighttime light levels change during post-conflict reconstruction and recovery periods? And finally, on energy, some research we did ourselves is how do patterns of wind speed affect the adoption of renewable energy technologies? So we tried to combine natural data collected by natural sciences to our surveys through this geolocation. Okay, now, of course, there are some running projects on the linking side of things, and we focus on three elements. The first is how we actually link. We want to offer easy access to the social scientists of Earth observation data. And for that, we use Copernicus data that some of you know very well because you're the ones delivering it. So we bring together this data for the social scientists, and we try to offer them software packages that allow them to link Earth observational data, Copernicus data, to their surveys or to whatever data set they have at hand that is more familiar for them. The second element that we focus on is actually how can we deliver the actual data because of their sensitive elements. So this is an infrastructure project. SORA is social spatial research data infrastructure. And here we create the spatial linking tools for the researchers, and we connect it to data centers that can allow them to have access to the data in the format they need. And that is specifically important because of the sensitiveness of the data, because we can't deliver surveys very easily with geocoordinates. I mean, we can't deliver them at all. Let's put it like that. And finally, the third element that we're looking at is the quality of the data. We have a competence center here in Germany funded by the Ministry of Education on the federal level. the competence-centered data quality in the social sciences. And here we're focusing on demand-oriented support for the evaluation and the analysis of quality of social science data. And specifically for us here in this context, it's important that we look into spatially linked social science data and their quality and where the mistakes or the gaps or the problems can come from. And here we have delivered a tool set on how to analyze this. So here, whoever is interested can come to us, and we can. There are websites already with the tools. And there is a project that is very close to my heart that is the one about Copernicus data, as I told you. And here we try to understand better the differences in the structure of the data. So we have tidy data in the social sciences, right? We have variables that are, in columns and observation that are in lines, and we have the values. So it's very tidy and structured. And now you come in, the natural scientists, and you bring us geodata that are all over the place. So this is a problem that we dealt with in the Copernicus element in the Copernicus data set, and we try to structure the data in such a way that we could create all kinds of different linking potentials. Imagine, within our observations, we have individuals that are located in a specific place, and they are time-stamped. So their answers are time-stamped. So bringing the information on geodata in has to do with how big is the area that is relevant for the individual, depending on the measure, and how big is the time scale that we have to look at. So if we have extreme weather events, how far away should the individual be? How big is the grid that we're looking at? And when did it happen in comparison to the moment that we asked the individual? So these kind of elements had to be tested and answered. And that is one of the difficulties that we faced here. The data cubes. So in this GESIS meets Copernicus, we developed a high-performance user-friendly interface, user-friendly to us, to social scientists. And we published R packages that include documentation, tutorials, and online compendia. And we identified core variables that we could use directly, and they are widely used by the social sciences. And also what we did is we took GESIS datasets that are widely used, for example, the GLES, the German longitudinal election study that is collected around the German election, and the GESIS panel that has a big variety of variables, so questions, and we linked them with the Copernicus data. So we're also exploring the potential of this, but we're also exploring the potential of linking digital behavioral data. For example, we have web tracking of individuals. So what is the media diet of individuals across time? So they are giving us their browser information, and we link them with Copernicus data to see to what extent an extreme weather event, for example, has an influence to the media diet of the individual. And the second thing that we did after this project is come to an end is the Earthlinks project that basically offered everything on a Shiny app so people can even play with it. And it looks like that. It's not ready yet, but it's getting there. I'll give you one case study to understand a bit deeper. Christmas floods, 2023-24. We had some floods in Germany. You can see on the map where it was. And the idea here was to link the emergency area with georeferenced survey wave of the GESIS panel and to see to what extent the distance to the flooding area had an impact on the way people think about the risk, climate risk. So as you can see here, let's see, here is the baseline. So before the floods happened, there was no difference on how people thought about this risk. So flood risk perception. So they didn't think anything about. So some people thought about the floods being a potential risk for them. Some people didn't. But the distance to the actual floods didn't play any role before the floods happened. So people were not more aware that in my place, but maybe there will be some floods happening. While after the floods, it's the pink line here, people who were living in areas affected or close to areas more affected actually increased their perception of risk from floods, while the further away someone lived from floods, the risk diminished. So after the floods happened, we see a differentiation of understanding of the risk assessment. It's not as pronounced as I would have hoped, but for social sciences, this is enough. So that's the other issue. This is only one example of what people can do with these kind of data, but the idea here is to just showcase this for you and understand how this works. And here you can see in the map that we created different distances from the areas that were flooded, and we only use localized data based on what we actually had collected. Now, to bring this to slowly close, I want to remind you that our data and our attempt to create a geo hub for our surveys is widely networked. So we are in the Leibniz Research Network on RF and Society. And some of you might find yourself there, maybe. Most importantly, we are offering also, we will be offering this information also through MEDEM, that is the Monitoring Electoral Democracy, where Hayo will be saying more about it. But what I wanted to add here is that GESIS will be offering through MEDEM a service center on the linking, and spatial linking will be one element of the linking, but there will be others. For example, linking on the basis of political entities or other entities, but it's not relevant exactly right now in this context. That's why I only focused on what is interesting for you guys here. So with that, I stop and I thank you for your time. If anybody wants to get in touch, this is my email, and I'm happy to respond to any questions. Thank you.
Thank you very much, Alexia. That was a very comprehensive introduction to GESIS as a research infrastructure and a lot of very interesting information. I just want to invite the audience to check the catalog of services of IRISCC, where we can see different services also given by GESIS. And I also want to remind that in a couple of days, IRISCC is going to open its third call for transnational remote and virtual access. And maybe it's a food of thoughts. Maybe if you want to combine your research with social sciences, this is a good opportunity. Let's move forward with the second research infrastructure. Let's keep those questions for later on. And we will have all the questions at the end. And let's move forward now with OPTED/MEDEM with Hayo and Marvin. Guys, the floor is yours.
Thank you. Let me just find the slides. Yeah. So thanks a lot. Maybe a few words before I get really started. In terms of maturity, OPTED/MEDEM is way less mature than what Alexia is presenting in terms of GESIS, and we're very much in the building phase of this infrastructure, which also means that I will probably use more words like we will do, or we would like to do, or you could do, rather than we have done and we have achieved, and to avoid confusion. So when we entered IRISCC, or when we were asked to participate in IRISCC, it was still OPTED. It was a design study, an infrastructure design study that was funded for a couple of years, very much on political text. This design study has become one part of the thing that we're now building, which is called MEDEM, monitoring electoral democracy, which is the infrastructure which currently is trying to get on the ESFRI roadmap. We actually have the ESFRI hearings next week. We're very optimistic and positive about the hearings and hope to enter the roadmap with the update in September. So, and basically many of the services and ideas we have sketched and OPTED with regards to text analysis have now been transferred to MEDEM, and that's why in the remainder I will be speaking about MEDEM rather than about OPTED. And we're also currently in the process of rebranding within the IRISCC project. So MEDEM. What MEDEM is trying to achieve as a European infrastructure is that it is trying to bring together various different types of data collections that are ongoing and that are happening and that have something to do with democracy, politics, elections, and so on and so forth. So what we see in the research currently is that many different projects, many different networks, many different national infrastructures, sometimes even comparative infrastructures have their own types of data collections, and these could be survey data, these could be textual data, this could be contextual data, this could be institutional data, and I'll say a few more words about those different types but they're very much working in silos and not integrating well. And our basic argument is that in order to understand democracy, and democracy is by definition a very complex thing to study and to look at, with many interdependencies and feedback loops between actors and institutions and so on and so forth. In order to do so well, we need to come to a better situation in terms of bringing data together, harmonizing data, linking data, and thereby allowing for comparative analysis, for over time analysis, and for process analysis between different actors and institutions to a much better extent than is currently the case. And so MEDEM is really trying to push this idea and thereby to unlock the potential of the data that's actually out there and that's oftentimes already being collected on voters, parties, media, contexts, and so on and so forth, and bring those together in a European infrastructure framework, harmonizing the data and making them interoperable and linkable. So that's our basic aim, and that's what we've been working on designing and establishing in the past years. Just to make that a bit more clear maybe to people who might not be political scientists and not working in this area daily. So consider a basic research question like, how does disinformation or information influence democracy, right? So if you think of this question, many things come to play. You can look at information from a macro level perspective, looking at legal systems and regulation of information flows, at media systems that regulate how information flows, at party systems that might differ very, very much on how they how communication flows, how advertising is regulated in these systems, and so on and so forth, right? Then you have meso levels in that. It's interest groups interfering, it's media outlets, social media platforms, that are part of the game. It's the political parties actually who are communicating, it's policy outcomes, legislation, parliaments, and so on and so forth. And then on the micro level, you could be looking at citizens, their attitudes, behaviors. And all these are not independent entities in democracies, but they're all interacting one way or the other. And so given that democracy is such a complex system, it's very demanding to study. And what's currently happening is that research is very much isolated. So you would look at people who study citizen attitudes and their media use patterns, for instance, or look at media outlets. Separately, even you could look at political parties and policy outcomes, and that's what's being happening. But that's about it. The next thing is that even if people study media outlets and citizens' attitudes, for instance, the measurement might be incompatible and very hard to harmonize, actually, to put these two types of entities or actors together to study them in combination. So the main message is that often the data that we have, and we have data on many of these different actors and institutions, the data is not interoperable and does not speak to each other. And that's making it very hard to actually get a systemic picture of democratic processes. And this is something which we push forward as an infrastructure. So we do so by means of having different types of data service centers. So we have data service centers which work on survey data and harmonization of survey data. We have a service center that works on contextual and institutional data, so electoral systems, political systems, but also parties or parliaments. And then we have a data service center on text data, which would include any type of media, social media, political communication that comes in textual formats, these types of data. And that's primarily where we come in, and which is also where OPTED has been coming into MEDEM in terms of trying to push this text or multimedia data perspective. As Alexia said, a lot of what we're doing then is about creating interoperability and linkage between data sources, and this is where GESIS comes in as hosting the linkage service center, for instance. We're developing a platform where all these things come together and where basically data can be more or less automatically merged at some point. We're having a training service center and a headquarters here in Vienna that's overseeing the building of this. So in short, again, you could think of MEDEM as sort of an infrastructure that brings together a lot of different, what some people would call mini infrastructures or data collections of different types of data, and makes them interoperable and harmonizable and interlinkable. From the infrastructure perspective, and you all know infrastructure building, so we've been in the game for a while already, and we're very happy to be where we are currently. It's sort of in phase 2, the design phase. We're slowly transitioning from design phase into implementation phase, preparatory phase, and then implementation phase. And we're in different stages in these phases, really. But what's important is hopefully getting the push of getting onto the S3 roadmap. The idea was born in 2008 already, with bumps up and down, and we've become much more active since 2020 approximately in terms of building this. Then we have a headquarter, we have the S3 application in. We're hoping, if everything goes right, to become an ERIC by 29, 30, 31 maybe. We've got a lot of support gathered now, individual scholars, institutions, we have a lot of data networks, and we're very proud of having 15 political support letters for the S3 application, actually from European ministries. So this is all very good news. This, just to give you an idea, is data that comes into MEDEM. And again, this is very different types of data. There's surveys, various types of text data, various types of contextual data. You see things like vote advice application data, as well as expert survey data, data on political candidates, and so on and so forth. So it's a very wide variety of data resources that come into MEDEM. Pan-European in Outlook, what we're currently building, and just very briefly going into some of the prototypes that are maybe closer to our involvement with IRISCC. So everything will come together in a platform that's called Atlas, which is not operational yet and which we're currently working on. And that's not the main thing here to talk about, but what might be more important than when we think about integrating MEDEM and the text analysis side of MEDEM more into IRISCC is two types of prototypes, or two types of services that are currently more or less working well. Marvin, do you want to say a few words about Meteor?
Yeah. One of the things that specifically comes out of OPTED is Meteor, which is kind of a meta inventory where, especially in the social sciences, computational methods is a fast-growing field, and it's probably sometimes hard for people to keep track of, or for new people to get an overview of the field. And we've tried to collect lots of things that are relevant to this field in Meteor to have linkages there. So we have both software tools, but also studies that use these tools. We have news media sources, which are, of course, of special interest to communication scholars or political scholars. We have how might you access these news sources, etc., and have tried to build that into an open source platform that's been developed currently, getting new features, new visual overhaul as well, and it will also form a core part of MEDEM. And if you want to, yeah. we're logging lots of these entries. It's a kind of a community effort that we have. There's a two-stage review system, but basically everyone is welcome to. It's free to access. It's free to register, and we're trying to have a moderator system, but a user-led system kind of participation and in creating entries. And we're trying to make all of it mostly useful, targeting kind of two audiences. On the one hand, people who are not maybe so well versed with computational methods. So there's the web page where people can access information and can look up information, but then also can be integrated into data analysis workflows because everything has an API that is free to access. So if you have kind of a dynamic setup where you might pull certain meta information that you need, you can also do that. And we're trying to, of course, link to other things as well using Wikidata IDs, etc., so that everything that we have in Meteor can also be linked with other data sources or pieces of data that people might have. We have a few screenshots also how that might look like. For example, this is an example of a content analysis study. So somebody has done that and looked at what media reported on in the European Parliament elections 2009. And this is all of the meta information that we have extracted. So what is this study about? It considered journalistic texts. It's actually a multilingual study because it considered many countries where European elections were held. And so all of these fields are also clickable fields that are then linked. So if you have the question, okay, what other data sets have used journalistic texts? Click on the category for journalistic text and you can find those. Maybe I'm interested in specific studies on Finland, then I can click on Finland, and then I can also find, for example, an overview of news outlets in Finland, etc., etc. If I then find a news outlet in Finland, then I can have meta information there, and then I can again see, for example, which commercial archives might give me access to data if I need data from that specific Finnish news outlet that I might want to study.
Thanks, Marvin. I should say that Meteor, the updated version of Meteor might go online tomorrow, so we're just a bit late for our webinar today, but it should be going online very soon at least, and we're continuously updating this. The other service which is useful in our context here is AMCAT. AMCAT is a tool for two things basically. So AMCAT is a tool where if you have raw text data, and that could be text data for media reporting about climate change, for instance, you can use AMCAT to collaboratively annotate, to collaborative code those data. It's got a management system for that. It makes things very easy to manage basically large-scale data files and then analyze those both manually but also computationally. And we're in the process of very soon also having a MEDEM-specific AMCAT instance ready and online. The other thing that, and this is a team that's been working on this actually. So AMCAT then can also used as a entry point where you can actually host and share data, and that's where things become important for integration in IRISCC as well. So this is a platform where you can basically store raw text data files. And based on metadata fields, people can explore what is available in terms of data on the platform, and potentially also get access to those data, either by being able to directly download them, but that's oftentimes difficult because textual data is oftentimes copyright or privacy sensitive, and so it's very hard to give open access to raw data. But we also have built in a thing which we call a non-consumptive research pipeline, where you can basically, based on the metadata, come with your script, analyze data in a secure facility and get the outputs of those analyses. So what we're currently looking at is having data that is relevant for IRISCC being available through AMCAT very soon, hopefully, to then have this as a sort of entry point for IRISCC researchers to look at data. This is just very quick. If you upload your data into AMCAT, this is roughly what it looks like. You could upload a simple CVS file into the system. and you immediately get some first outputs in terms of what outlets are covered in there, for instance, and what time frame is covered. So you get instantly some metadata that you can look at it, that others can also explore to see to what degree this is useful. And then the non-consumptive research is basically the analysis part that you get without access to the full data. And that we hope will be very important, because that really allows sharing data without sharing data, right? So we can share access to data without sharing the data, and that for the field of text analysis research will be very important. As I said, UMCAT will serve as an exit point for IRIS relevant data entries and annotations in the near future, and I hope with the next update of the service catalog we're actually there. Just briefly on how all this might be relevant for IRISC. So obviously, as we all know, I guess, climate risks are not only physical phenomena. They play a role in media and public discourse, and political discourse, parliaments, political arenas, and so on and so forth. From a social science perspective, you could look at climate risks not only as natural science data, basically, but as socially mediated and negotiated and constructed things as well. And this is where social science data, in particular, maybe discourse type of data as we would have it, becomes relevant in terms of shaping public perceptions, in terms of signaling political debate or media framing, parliamentary decision-making, policy and policy outcomes. Protest could be part of what one could look at, potentially misinformation, counter discourses. So this, if we have a set of raw textual data, could all be facets that could be relevant to consider in terms of climate change and climate risks. And I think I said all of this already, more or less. Again, I don't have nice research questions as Alexia had, but again, some ideas of what could be done here. Obviously, it would be a very easy use case probably to link extreme weather events to media discourse intensity on these, for instance. You could look at projections and parliamentary debate on climate modelings or climate risks. You could look at flood risk maps and local political mobilization if you had the data, and things like the longitudinal linkages, temperature anomalies and shifts in climate salience. If you look at very long time spans, that could be very interesting actually to do, and some have started doing so. Drought prevalence and agricultural policy debate could be something. It's so just to make clear that there's various linkage points that could actually be worthwhile exploring. Important here is really that that's not always going to be easy. You need primarily temporal and also geographical linkage keys to do so. And often for the type of data that we would have, and when it comes to text data, especially the geographical dimension is much less fine-grained than what Alexia has been presenting, right? I mean, we're looking at national discourses. If you look at platforms, it's not even national. But you could look at user locations again. But it's much more tricky, I guess, to come to a much more fine-grained picture here on geographical issues. So this basically also indicates that the raw data that we might be having and that we might give access to is not geared towards immediate analysis, right? So raw data means, it could be newspaper coverage of a single newspaper over 20 years. But then the challenges are, what is climate related? What is climate risk related? What is maybe related to droughts or floods or fires or whatever we're interested in terms of hazards? And this requires transforming those data, annotating them, and harmonizing them. I want to give Marvin 5 more minutes maybe to speak. So I'm skipping the use cases again: extreme weather events, political discourse, risks translating into policy could be use cases, but Marvin should speak about the data that we're currently working on more concretely.
Yeah, so social scientists often do a lot of not very efficient things because a lot of people do the same thing that other people have been done because sadly there's not only I don't know. There's not only social issues that stand in the way of data sharing, but actual legal issues. Just because I have collected newspaper data and someone else would like to do a study with that, means sadly I can give it to you if I risk operating in very gray illegal areas of the law. Then there's also certain biases in which kind of data, if available, are available. There's often a kind of English language bias. There's a bias towards Western European countries. And this is kind of an application. This is one of the things that we're trying to provide a bit of an infrastructure component, show a bit what we could do in terms of climate change and stuff with text data, and where we're trying to address these points. So we're trying to collect a corpus of media reporting. I think Haya can move to the next slide if you want to. Exactly. So we're trying to actually cover a few geographical areas that maybe have not been served so well currently in research, often where we've identified most wide-read news outlets in countries. There we already started just with the question of, which news outlets are they actually? So we went to survey data, tried to see, who are popular outlets in each country. And we're trying to, with this, have both a bit of systemic perspective of having different media systems and different political systems, which are of interest to us. But then also from a geographical perspective, it would be interesting to have countries that have sea access, but also countries that have mountain regions. If we're trying to look at climate risks or also climate systems, then it would make sense if we don't just have Germany and Austria because they are nice countries, but they have very limited they have some geographical diversity, but we're missing a lot if we're not covering other European countries. So we're covering all of the blue shaded countries, trying to cover them. We've been gathering data so far. We're trying to extend it also a bit beyond. Data gathering is a fun process that's definitely recommended for everybody who wants to have a fun time. But it's going increasingly well so far. And we're trying to basically do two things that we detail on the next slide. The steps that we do, like how you mentioned, just having texts, then we just have texts, news texts, and that's not really useful for either us or maybe other people that want to use them. So the first question is, of all the news that are published about celebrities, about local deaths, about how to train your dog, how do we identify things that are related to climate change? For that, we built a simple search string based on previous studies that have used it to find that in climate change. Then actually we're dealing with, I think, 22 languages here. Then we needed to translate and at least feasibility check that for the other languages. And again, then we just have reporting on climate change, and then we could only tell you, do they say more or less about climate change? Again, not so interesting yet. So we're trying to also work within the IRIS framework of looking at specific climate risks and specific climate systems. There might be some divergences of things that are of real interest to natural scientists and that are of absolutely no interest to journalists. So, some risks might be very potent in terms of actual climate perspective, but very non-discussed in research. So there's only certain things that it makes sense to look for. So we're trying to build a catalog of risks and also systems that we can then also identify in these texts. Again, we need to deal with all of the other languages so that we can ideally say how different countries experience and have discourses around risks and how they might also be influenced, of course, by where that country is located. The kind of next steps that we're trying to do is refine all of this, also integrate it into the catalog of IRISC, and then also using AMCAT actually make it available for other researchers so that other researchers can be spared the really fun process that we've had of data gathering and they can more easily work with that. We'll also be present at a few conferences this year for, kind of computational social scientists where we're going to promote the data that we've gathered to have a bit of interest there and knowledge about that, and also invite potential collaborations or research that could work with that data.
Final sentence from my side. Thanks, Marvin. So with this pipeline that we're building, identifying risks and systems, we can obviously also look at other data. Parliamentary debate data is very easy to get to. Party manifestos, for instance, is data that we have easy access to. social media data will become much more difficult and will be more an on-demand issue to look at. And obviously with the raw data, we have a lot of flexibility to look at other features as well if that's of interest. So I'll leave it here. Thanks for this.
Thank you very much, Hajo and Marvin, from my side. It was a very, very comprehensive approach to them. I just want to, in the name of IRISCC, thank the three speakers today for showing us their research infrastructure and also all the participants in today's session. Just a reminder, as we were giving it in the chat, or you can find it also in the website, that you can register yourself for the upcoming webinar sessions. And without further ado, because we do have already some questions, I'm going to stop the record and we're going to move to the question sessions. So thank you very much for the participation. And now I should have stopped the recording here.